What?
If I want to use my extension, do I just tell you or do I email you?
No, you must email me to have a paper copy. And paper trail, while we're talking about it, there is it's the reading for Purim. What's it called? Mahila. Right. So if you're gonna go and like you're gonna miss the test, clearly, you need to let me know before. You can't just like not show up to class. You have to let me know before. So ideally, let me know by the end of tomorrow. Like let me know. Same thing as extension rules. Are you going to take an extension? Email me the night before. Ideally, like decide. Are you going to go to this reading? Are you not? Because here's when you're going to make it up. If you're going to the, what you said? Megillah. If you're going to go to the Megillah reading and miss G period, you will make up your missed test during lunch on Thursday and bonus on Friday. If you have extended time, that gives you enough to like get it done before the weekend. Cool. Questions about that? Alright, so we're all on the same page. If you're going to go to this reading, you're going to let me know. I mean, you should probably like know even today. So email me tonight. Like let me know so I can like plan on it. That gives me more time to prepare and like have the test ready. Cool. Example 5. So we're going to finish example 5, go through the last example that we didn't do for 7.7. Then we'll go through 7.8 today. So for the test, I have the practice test today ready for you. We're going to go over it tomorrow in class. All right. So example 5 says solve round to the nearest 10,000. Round to the nearest 10,000. So a little warm up. How the heck would I even like get this? I'm trying to solve for x. Right now I'm taking log of 5 times x, and then I'm taking that whole thing and multiplying by 2, and it's going to be 6. Like, oh my gosh, it's too much. How do I...
Make 2 an exponent.
Huh?
Make 2 exponent.
Maybe. Jonah, a question? Are you have the idea? Yeah?
I have an idea that
Okay.
could be wrong.
Okay.
You could move 2 ln to the other side, therefore dividing it by 2.
I'm going to divide by 2, but ln is a... my pen is breaking. ln is like a function. It's an operation. It's not. If you have a multiplication symbol, it's not like you can divide by the multiplication symbol. Like that doesn't make sense. So I'm going to divide each side by 2. This is really not good. 2. This is, what the heck?
Can you just write it with your finger?
No.
Yeah.
What? I could like make a dot. I can't write with my finger.
You could change it.
I don't want to.
Sure.
2. So now I have ln. I think this is how it broke in the first place, is I probably pressed too hard. That's exactly how it's broken. Okay, cool. Ln of 5x equals 3. How can I get rid of the ln? What can I do? Do you have an idea? Yes, Jonah.
You would, for each side, you would do whatever you did last class.
Put each one as a power of e.
Yeah.
As an exponent for e. So I have e to the ln of 5x equals e to the third. What happens to the e in this ln?
Oh. Cancels out.
Yeah, so I literally have 5x. 5x equals e to the third. So x equals e to the third over 5. If you put this in your calculator, what do you get?
You have that.
Exactly.
I'm confused.
Okay. Which part? Do you have an idea?
How does the ln
So I put each side as a power of e. It's like I raise each side. So it's one of our tools. It's one of the things that we can do. All right. Just a reminder: shouldn't have your phones out. Shouldn't be on your desk. Shouldn't be on your pocket. Sure. I say no. Okay. Should have your phones out. Should be totally put away. So if you're on your phone, Or if I see your phone, like, I shouldn't see it at all. Just like a broken record time. If you're chit-chatting with a side neighbor, are you paying attention? I don't know. I can't tell. All right. Now we're going to go on to continuous interest. So we talked about compounded interest where it was where like once a month we compound it. We find how much money we owe. Maybe you compound your interest once a year. Maybe you compound it once a month. Remember the equation where we had an n in it? So I had a is equal to p times 1 plus r over n all to the nt. Well, so the n here is the number of times we're compounding. What if we're not just compounding, once every couple months? What if it's not even like once a week, once a day, right? Once a day, we're going to be like earning interest on the interest we already earned. Like you're getting interest on the interest on the interest. Like it's growing. What if instead of like every day, what about if I compound every hour, every second? That'd be crazy, right? Literally every second. Ooh, guess what? I just earned a little bit of money on the money I just made the last second. Yeah. Some people are so rich that, I don't know, like $50,000, like the equivalent of a penny to an average person would be like $50,000 to them. It's just like chunk change.
Like Mike Trout. Oh, do you Mike Trout?
One more time.
What?
Talking about Mike Trout?
Yeah.
Awesome. That has nothing to do with math. Okay.
He earned a large amount of money.
He did.
Good talk. It was not.
Yeah.
So, what?
All right, let's focus. Let's focus. Huh? All right, so my point is, what if we're not just compounding interest every second? Jonah, turn around. What if it's like every microsecond, like an infinity number of times per year? So this is if n goes to infinity, meaning I'm like continuously compounding. I'm not letting there be any space between the compounding. If it's continuous, then this goes to a equals p times e to the rt. It's called APERT. Have you heard of APERT before?
Never.
Fun. Okay. APERT. So p is the principal, r is the rate in hundredths, t is time in years, and e is just the exponential, 2.714, whatever. What? All right, so if I do example 6, suppose you deposit $700 into an account paying 3% annual interest, compounded continuously. So the key here is continuous. If it's continuously compounding, that's when we're going to use APERT. So if we deposit $700 into the bank account, then this is my principal. And I'm paying 3% interest, so that's my rate, but it's not, I'm not going to put in 3. How do I convert 3% to a rate? 0.03, because it's 300ths. Compounded continuously. Balance after 8 years, that's my time. And I'm wanting to know the balance. A equals P times E to the RT. So A is equal to the principal, 700, times E to the 0.03 times 8. So let's practice putting that into your calculator. What do we get? Do you want me to show you how to do it again? No, because I already showed you. Okay, cool.
889.874.
889.87. Cool. So how much money we'll have is $880. Oh my gosh. $889.87. Not too bad. I mean, it is 8 years of interest and you only made $190, but hey, it's free money. Literally, the money is working for you. All right, how long will it take? So this was solving for A. So this guy is solving for A. Let's see what the others solve for. All right, how long will it take for the balance in your account to reach at least $1,200? So I'm solving for time. I still have the same principal. I'm starting with $700. I still have the same rate, 0.03%. I'm sorry, 3%, 0.03. I know how much I'm going to end with, right? A is going to be $1,200. And I'm looking for time. I use APERT. So I have 1,200 equals 700 times E to the 0.03t. Okay, first step. How do I get this by itself, Sophie?
You would say what E to the 0.03, right? No. Oh, so then you would divide by 7.
Divide by 700. I have 12 over 7 equals E to the 0.03t. I'm really trying to solve for time. That's in my exponent. So how can I get the exponent down? How can I get rid of this base? Do you have any ideas? We're going to take log of both sides. Liana?
Log of 12, 7.
And log of 0.03.
We'll take log of both sides. So I'm going to take natural log. Why am I taking natural log? Why am I doing ln?
Because E equals ln.
Because, exactly, ln is the same thing as saying log base e, because I wanted to have the same base that I had in my problem. So I have ln of 7 over 12 equals, let's see, ln and e on the right side, they more or less cancel each other out, so I have 0.03 times t. Last step to get t by itself is to divide by 0.03. So I have ln of 12 over 7 all divided by 0.03, and this will be my time.
57.
Should be like 18 years.
12.7 divided by 0.03.
No, it's ln of 12 divided by ln of 12 over 7 all divided by 0.03. Yes.
I get this. I'm just confused how the 0.03t went from an exponent to like regular number.
Okay. Yeah.
Like,
So
would it just be like
when I have ln of e to 0.03t,
I know that ln.
this is the same thing. This is the same thing as saying log base e of e to the 0.03t. I can use rule of the power property, so bring it out front, 0.03t times log base e of e. It's an e. And I know that this whole segment right here is literally equal to 1. So we've gone over this a couple times. That's why I kind of skipped a step. And that's how I got it by itself on the right side. Okay. All right, and then, so we've done a problem where we solved for A, right, the balance afterwards. We did a problem where we solved for T. Now, we're going to solve for P, the principal. How much would have to be deposited in order to reach a balance of $1,500 after 12 years? So this part B and part C would be great, like, bonus problems on the test, because it's a little harder. All right, how much would have to be deposited in order to reach a balance of $1,500 after 12 years? So time is 12. The rate is still 0.03. Let's see. Balance of, so A after, the balance after, why is this? 1,500, and I'm trying to solve for P. So I'm going to use APERT again. $1,500 is equal to P. times e to the 0.03 times 12. If you put this part into your calculator, you get 1.433 times p is 1500. To get p by itself, divide by 1.433. You find the principal would have to be
1046.5.
Yep, divide both sides. Cool. So that's all we missed from yesterday. So this last part is just solving exponential problems. All right. So we've gone over continuous compounding. So we just did. We've gone over compounding at like certain intervals. So we're going to talk about exponential growth and exponential decay. So it's very, very similar to compounding interest, right? We can see that like a PERT is just like y equals a times e to the kt. That's population growth. You can have positive growth and negative growth in population. It's literally the difference is having a negative decay. So we still have, what?
Isn't all decay negative?
Have a negative rate of growth is a decay. Yeah, decay is negative, but I just mean your rate of change can be positive or negative. Are you growing or are you like shrinking? So carbon dating, knowing the half-life of carbon-14 is useful in dating organic materials. Carbon-14 has a half-life of 5,730 years. Determine its value of K. Okay, so what I'm trying to find, I'm going to be using this decay. What's called population growth, but I'm going to use it. So I know it's going to be decreasing, right? I know that how much I start with, half-life is literally the amount of time it takes in order to have half of what I started with. Half-life is the amount of time it takes to get to half of what I started with. Okay, so what this is going to look like is, let me just write the equation, y equals a times e to the kt.
Wouldn't it be negative?
I am going to have a negative rate of growth. So when I'm determining the value of k, we already know it should be negative because we're going to be shrinking. So how much I end with is going to be how much I start with. And my time is 5,730 years. So here, A is how much you start with. So I'm trying to find how long it takes to get to half of that. The ending amount is literally just going to be half of A. Is that okay that I've just plugged that in?
Maybe do 573 whatever times 2.
No, because I want to solve for K. I'm trying to get K by itself. So I'm going to divide both sides by A.
I was going to say that. And then A would get rid of itself.
Yep, A is, 1/2 is equal to E to the K times 5,730.
And then would you do
The ln.
ln of both sides. Ln of 1/2 is going to equal ln of E to the K times 5,730.
And so it would be ln 1/2 equals K times 5,730.
K times 5,730.
You can solve for ln 1/2 then.
Yeah, you just plug into your calculator. But, so K, you just divide both sides by 5,730. So the value is going to be ln of 1/2 over 5,730.
That's negative 0.0000121.
So negative 0.000121. Is that what you got? Okay, perfect.
Wait, 3 zeros after?
Is that what you got? 3 zeros?
Yeah.
Perfect. Okay, so that's a very, very small rate. What would this be in a percent?
It would be 0.
Negative 0.001.
This would be what it would be as a percent. So that's very slow. That's very, very slow. That's a small percent. But that makes sense because it takes 5,000 years just to lose half of what we started with. Yeah. But there are other, like carbon-14 is actually pretty fast as far as dating goes. It's uranium. Actually, let's see, what are some other ones? Strontium, zircon, they take way longer, like billions of years. This is how we found out the age of the Earth, solar system. We did dating like this. You okay? Your eyes look, you okay, Max? Okay. What?
What?
I'm just trying to make sure everyone's okay. Chloe, sit up, please.
I never said anything bad.
All right. Example 2.
Wait, question.
The half-life of the half-life of sodium-22 is 2.6 years. Determine the K value in the equation of decay.
Can I do this?
Sure. Talk me through it.
Okay, so you do, what would it be K equals?
I'm trying to
Okay.
find what K is.
Okay, so you put Y, which is the years, so it would be 2.6.
Y is not the number of years. Y is the final amount.
Alright, so would you just do, a half, A equals, negative 22?
No, this is just, that's sodium-22 is just the name of the mineral.
Yeah,
E
I'd like to
to
pop
the
one
K.
on this.
2.6. It's just like the previous problem, but instead of saying carbon-14, we say sodium-22.
Okay,
It's just
so
a
I got
different.
this. So you divide A to both sides, so it cancels out the A, so it would be a half equals E and K to the 2.6.
K times 2.6?
Yeah, and
Okay.
then you put ln on both sides. So
ln
it'd be
on both
ln
sides.
1/2 that. So cancel the E, so you get ln 1/2 equals K times 2.6.
Mhm.
And then you would divide 2.6 to both sides to get the K value itself.
Yep.
And then whatever, like, that's what it is.
It's gonna be 10
Negative 0.266?
No.
595.
Okay, so this is like,
67.
26%.
it's like about negative 26.6%. Yeah, that makes sense, because 2 years versus 5,000, it's going to be much bigger. But this is, no. But since, okay, I'm trying to like have you understand what I'm doing. I found what K's value is. You don't have to do it as percent. I'm trying to give you context so you like get an idea of what a good percent should be for a problem. So here I want the equation of decay, so I'm going to be rewriting this. I'm going to be leaving y and t. Those are like the things that are changing. I could plug in a time value and it'll spit out a y value. So the equation of decay is going to be y is equal to, oh no, do I need to find out what a is? No, I think I'm okay. If I put that as 1, that's fine. Y is equal to e to the negative 0.266 t.
So that's the answer?
A geologist examining a meteorite estimates that it contains about 10% as much sodium-22 as it would have when it reached Earth's surface. How long ago did the meteorite reach Earth?
Can I do it?
I just have a question.
Yeah.
The last one. Do you have to put the percentage?
No, I'm trying to have you understand context with what a like trying to help you guys understand, like, okay, would this be a good K value or not?
Yeah.
If it's like a really small time, 2.5 years to get rid of like half of the stuff, okay, that makes sense. It'd be about 26%, because the first problem we did, we found that it was like 5,000 years to get rid of half of it, and we found a really small percent. All right, Iris, sit up. Chloe, sit up. All right. All right, so yeah.
So when I'm just a little bit, because it says decay, so like
Yeah.
I thought that meant that it has to be A times E to like the negative KT.
It is negative.
So then
I do
why
have
are you
negative
not
K.
writing that the negative in the like first equation?
I just write the general, because if I would write a negative there, then I would find a positive K value,
Oh, so it's just
because
telling you
it's
that, like,
taking it takes into
negative.
account the negative. Yeah,
Okay.
takes into account. Okay, so 10% as much sodium as it would have when it reached Earth's surface. So what this means is, let's see, 10% as much. So I have 0.1 A is equal to A times E to the negative 0.266 T. How I found that is we have this equation here. I guess I could have put an A here, but it's like, basically it's going to be 0.1% of what I like started with. I assume like, okay, how much I start with, I'm just going to have that be equal to 1. So down here, I have 10% as much as it would have when it reached our surface, so I only have 10% remaining. 10% as a decimal is 0.1. Matt, we got, Jonah, sit up. So here is 100% how much I started with. If I only have 10% left, that's going to be 1/10 of A. 1/10 is 0.1. Yeah, yeah. 1/10 is 0.1.
No, that part makes sense.
Okay. So you understood where this came from? Not really. Okay. So let's break it down. What's the problem? Like, where were you confused?
It's more confusing when we start solving.
Okay.
No, it makes more sense. When you start solving.
Yeah.
It makes less sense. Setting it up is
Wait,
more.
are we solving?
So it's clear where this came from. This is my y. This is how much I'm going to end with. So this is how much I end with. This is how much I start with. This is my rate, and we found that it was negative and decreasing, and this is the time. And this comes from A equals A e to the kt, where here k is my rate. They just wanted you to have a different variable for rate because it's talking about, like, you know, continuous growth, population growth, not necessarily like money growth. Okay, so if I have 0.1A, more or less the original amount cancels out. That's why I'm not too worried about what it actually is, because I just have 10% of what I have originally. I have 1/10 of the original value. So the A's cancel out.
Then you can set it to ln.
I can take natural log of both sides. So natural log of 0.1 will equal the natural log of e to the negative 0.266t. So I have ln of 0.1 is equal to negative 0.266t. Because the ln and e like cancel each other out, I'm left with just the exponent. I could walk through this again. Jonah, wake up. Iris, wake up. Please sit up. Divide both sides by negative 0.266. You find the time is equal to do you want me to show you how to plug this into your calculator? Are we okay? Does anyone want me to show you?
Yeah.
Okay. I bias it up. Okay, so if you plug it in, what do you guys get? 8.656 years. Okay. It's loading. Okay, let me go to the home screen. I'll go to calculate. Oh my gosh. Okay, so I want to take natural log, so I have to do control e to the x, alright, because that takes me to the blue that's on top, which is ln. So 0.1, oh my god. Just a second. Negative 0, no, it's not negative. 0.1. Come on, I pushed 1. Why is it not going? Okay. And then dividing that whole thing by negative 0.266. Oh my god, come on. 8.656. Awesome. 8.656 years, cool. Alright, example 3. In 2007, the population of China was 1.32 billion. In 2000, it was 1.26 billion. Okay, so in 2007, this was the population. So this is how much we end with. So this will be my y value. In 2000, it was 1.6 billion. So this is how much I'm starting with. So that's my a. How much is the time? From 2000 to 2007? 7 years. And I want the k value for China's population growth. So I know y is equal to a times e to the kt. I know how much I end with. 1.32 billion. So I'm just going to put 1.32. I know my answer, like, right. I'll be okay. 1.32 billion is equal to how much I started with, 1.62 billion times e to the k times 7. So let's put 7k.
So you can do.
If I divide both sides by 1.26 billion, you see the billions like cancel out. Why am I dividing by 1.26?
Because that's how much you like your outcome.
Yep, that's how much I started with, and right now 1.26 billion was being multiplied by the e. Okay, 1.32 divided by 1.26, what do you get? 1 point, louder? 1.04762 equals e to the 7k. I'm really trying to solve for this k value.
So you can put it in ln, natural log.
So I'll take natural log of both sides. So I'll take natural log, ln of both sides.
ln equals 1.
ln of e equals 1. So this part right here goes away, and I'm left with just the 7k. So I have ln of 1.04762 is equal to 7k. So if I divide both sides by 7, I find that the k value will be ln of 1.04762 divided by 7. So what do you get?
0.006646.
Is this what you said? 0.006646? Okay. What would this be as a percent? I know this is not what it's asking for, but
0.6.
0.66%. Okay, that's a pretty solid percent.
Did you split billion after that?
Nope, because it's not billion. Billions cancel out. Billions cancel out right there. Okay, when will China's population reach 1.5 billion? Okay, so I can write the general equation for China's population. I know that y is equal to the initial population. The initial population was 1.26 billion times e to the k, so that's 0.006646 times t. That's the general equation. I could plug in any time and I could find out what the population would be. Instead, what I'm gonna do is I know what population I want to reach. I'm gonna solve for time. I'm gonna see how long it takes to make it that way.
Your y is 1.5.
Exactly. I know my y. My y is gonna be 1.5. So I have 1.5 billion. I need to get a new pen. All right. Is equal to 1.26 billion times e to 0.006646 t. Divide by 1.26 billion on both sides.
1.1904.
Hold on, I'm gonna have you repeat that in a second. Okay, so these cancel out. We're left with, what was it?
1.1904.
Is equal to e to the 0.006646 t. Okay, if I'm trying to solve for something in the exponent, what do I do on both sides?
Divide all right.
I take natural log of both sides. Take the log of both sides. So remember, when you do a logarithm, it gives you the exponent. It's another reason why on the right side I'm left with just what the exponent is. All right, and then last step to solve for t, divide both sides by our lovely k value. Let's see what our time frame would be. Where's our time here? Do we know? Carson, did you plug it in?
26.2348.
26.2348. Okay, so it's about 26.2 years. So this would be in 2026. But okay, what's it asking for? The year or how many years? In what year? When? When? Okay, it's asking when. Not in how many. Not how many total years, but like when. Okay, so 2026. Probably a fifth of the way through the year, so probably like February 2026. There we go. That's when. I'm telling you the date.
When did you get that?
Well, I started in 2000. And if it's 26.2 years after 2000, that would be 2026. Okay, so that is, so I'm going to change, kind of like for last time, I'm going to have a worksheet instead. Let's see how much we could get through. Cool, it's extra credit, there you go, you finish it. Because this is 8 problems, I like these better, so there you go. Guten Tag, there you go, alright.
Is that instead of homework?
Yeah, so instead, if you already did this, guess what? Go ahead, turn that in, whatever, you know. I'm not gonna pass, you know, we're gonna be like, no, don't do extra work so you're better prepared. So yeah, let's see if we can get through like, you know, 2 or 3 of these.
Are you going to give us all the equations?
Yeah, I'll give you all the equations on my test. You just have to know which ones to use and when. Yes.
Oh,
What? That is what I said.
Oh.
Are you gonna put the answers for these online also? No? We're not meeting with one.
What? I'm not giving you my like.
What's your
password
social security
question.
number?
month were you born?
These are, you know what? That's what my bank asked me, so
What is it?
I'm not telling you. What's the middle name of your aunt? What?
What's the name of your
So
first
you
child?
didn't know
What was
Paul.
your childhood nickname? No.
Paul
What
Holland.
street did you grow up on?
What's some of those other questions?
What's your mom's main name? That's a good one.
What's
your question?
Remember that you know this? Did you know that? You're okay. You guys are all like dragging.
You want to know why? Because this shit's hard.
We're talking about horoscopes.
Like horoscopes?
Horoscopes.
Is it because
Heck no, Matt, you're
Aries
moving
and
over
retrograde?
here. Leanna's being a bad influence on you.
Was that
Alright. Talk about horoscopes with him? Ooh. All right, let's go through some of the homework problems.
It's like which
Can you move that over to the side?
What?
You already
Move what?
Matt.
Wait, what?
Didn't you move Matt already?
Yeah, he's supposed to be sitting over here, but then like, I don't know. He felt lonely one day. 'Cause I think Maya was gone because I was gonna have him sit there. He promised he would work better over there, but I don't know if this is true. All right, let's see how much we can get through. All right, how many hours will it take a culture of bacteria?
Guys, stop talking.
Do you not want to? That's cool. I mean, you have 7 minutes with me. Do you not want to like pound out some of your homework? Yeah, let's do the homework. Cool.
Cool.
All right, how many hours will it take the culture of bacteria to increase from 20 to 2,000? Use K value. Okay, so we're doing it in terms of hours. So that's what my rate is in. So I have y is equal to a times e to the kt. Let's fill it in. This is my a because that's how much I start with. I start with 20. My y is how much I end with. I'm ending with 2,000. Ethan, you writing this down? And clearly this is my k because I told you what it was. So, all right, so let's plug it in. So I have 2,000 is equal to 20 times e to the, let's see, 0.614 t. I need to solve for this time. I need to get it by itself. If only the pen would work. Okay. Okay.
Wait, that's T or K?
It's a t. There. Divide by 20 on both sides. What do I get on the left side? 100. Awesome.
Okay, wow. Okay, no need to.
Okay, now that I have that, how can I like get the t from, okay, we're gonna ln, we're gonna natural log both sides. Take the natural log of both sides. I have ln of 100 is equal to, what happens with this ln and this e? It just gives me what the exponent is. So my time will literally just be ln of 100 divided by 0.614. 7.5 7.5 hours.
How far? Oh, so you just want us to go like
Because you said 7.500. That's good. All right. Because look at K. K had like 3 decimal places afterwards. This is fine. Okay. One question. Down. Do we have questions over this? It's just getting the hang of it, more or
Will
less.
you post this over weekend?
Maybe I'll think about it.
I'm gonna have serious issues trying to do this one.
Actually, I'll work on it. Okay.
Thank you.
Radioactive decay. A radioactive substance has a half-life of 32 years. Find the constant K in the decay formula for the substance. So half-life means how much I'm ending with is half the amount I started with. So we're going to use our original y equals a e to the kt. This 32 years, surprise, it's our time. So I'm ending with half of the amount I started with. This is just like a problem we've done before. Twice, actually.
Oh, may I guide you through this?
Yeah, let's do it.
Perfect. So you would divide a to both sides, so we're in the a, so it would be a half equals e, then k times 32.
Yeah. Okay.
And then you would put ln
Yep.
and multiply.
Take, we're not multiplying by ln, I'm taking log of both sides. Log is an operation, right? It's kind of like multiplying or dividing, taking a logarithm, right? It's a verb. Taking a logarithm, it's a verb, it's an operation. Okay.
It's like running, it's logarithming.
Okay. All right, so I have ln of 1/2 is equal to ln of e to the 32k.
And the ln e equals what?
So I have ln
And
of 1/2
equals 32 times k. Yeah. you would divide 32.
Awesome. So what do we find for our constant? Is this okay? Can you see it? Okay. It just takes practice. It just takes practice.
We have any more? Negative 0.021661.
So you said it was negative 0..
0.21661.
Okay, that's fine.
Oh, is it okay if I do negative 0.0217?
Yeah, that's fine. Do you want to try one more? Or are we okay?
No, we're good.
All right. So that's 2 of your 8 problems. Not too bad. I feel like we did enough examples, so you'll be okay. See you tomorrow. I will give you the practice test before you go. And then this is what we're going to do in class tomorrow. I just figured if you want to